Bismillah ar-Rahman ar-Rahim. This is Muhammad Ans, and my group members are Zohaib Munir and Armahan Tahir. They will be presenting by their own. Today, the course code is MT240 and /240L. So the project is HBridge. Now we are going to move on to introduction. Now, what is HBridge? In simple words, what does HBridge means? HBridge means rotating the motor in whatever direction you want. For example, rotating the motor in clockwise and anti-clockwise direction. Now, H-bridge is very important in industry. For example, H-bridge is used in robotics, arms, automation, electric vehicles, and appliances where precise motor rotation is required. Now, we can have a discussion on what thing to use, like switch or a BJT transistors, but here by controlling the switching of the transistors in the circuit, the motor direction can be easily changed. Now, this was the introduction. Moving on to H-bridge circuit. Now, what is H-bridge circuit? Now, H-bridge circuit is designed to control the direction of flow of current in whatever direction we need or we want to. For example, H-bridge is a type of electronic circuit that allows control over the direction of control flow in a load, such as motor. Now, 4 switches are being used in our case that are arranged in an H configuration. It depends, you can use them in an H configuration or you cannot, depending on your requirement or your need. Now, moving on to the circuit design. Now, this is our PCB design. Now this is our PCB design. We have used BJTs, transistors, resistors, diodes, T-block, and switches. Now, if I move on to the 3D visualization, you're going to understand better. Now, the green things which are the components, these are called T-block. The T-block is used because we don't have the visualizations of that component in Proteus in PCB. Now there are these resistors and these diodes, the optocoupler, flyback diodes, and the transistors. Now moving on to the schematic diagram. Now you are going to understand what's happening here. So if you see on the right side, J3, the T block number 2, it is a switch. We couldn't use the switch and or PCB design. We used it manually. So consider the T block 2 and T block J3 and J2 as a switches, okay? And the T block and the J1 is a voltage source, okay? And at the right we have 9 volt that is supplying, okay? That is being supplied. Now coming to R5 and R6, these are 1 kilo ohm resistors. Then this is PC817, which is an optocoupler. Now we will discuss what are they doing, what is their requirement, what are their functionality, what are their applications. All we will be discussing everything in detail. After that comes the resistor, the diode. Now what's happening is, in this middle you see a motor. The motor is connected with diodes, 4 diodes, okay? Now diodes are being further attached to the BJTs, okay? These are NPN, okay? NPN are being attached to the resistors R1, R3, R4, and R5, okay? These resistors, the R3 is connected to PC817, which is the U1, and same R3 is connected with R2. R1 is connected with R4, and R1 and R4 are connected with U2. Similarly is the case with U1. The U1 is attached with resistors R6 and U1 and U2 are attached with R5 and R6 respectively. Further, they are attached to the switches where you can control the movement of the motor, and they are attached with a 9 volt voltage source and J1, which is the voltage source that is being provided. Now, the node where BJT Q3, D3, D4 and are attached, and the BJT is attached, they are grounded. Similarly, the voltage source J1, the one terminal is connected with the T block J2, and the other wire is grounded. And by this circuit we are getting our desired outputs. Now, moving on to the automated test bench. Automated test bench. Now, what does automated test bench means? Automated test bench means making a circuit by implementing some things that make it automatic. For example, not implementing the circuit or not the circuit shouldn't work manually. It should be automated. It should work on its own. Now, how are we going to do this with HBridge? Sorry. So with HBridge, what we used is an Arduino. Now, what is an Arduino? An Arduino is our style microcontroller board that can be programmed to control an HBridge or any other circuit. Now, an HBridge is circuit configuration commonly used to control the direction and speed of DC motor that we discussed earlier. Now, by utilizing the digital and analog input and output pin of the Arduino. Now, what does this say? It says that Arduino have pins, input and output pins. By configuring and understanding those pins, you can control the output and input. It becomes possible to send control signals to the HBridge. Now, from Arduino, you're going to send control signals to the HBridge circuit, enabling precise motor control, meaning controlling the motor according to your need, moving it clockwise or anti-clockwise. The Arduino can generate necessary control signals. The main purpose of Arduino is to generate control signals that are sent to the circuit. Now, Arduino uses a program. It could be of any language, but we're going to use C++. It uses C++ language that determines the desired motor direction. You give commands, you give the code of your need, and the circuit performs. Now, these signals are then transmitted to the HBridge. Now, when these signals are transmitted to the HBridge, now which switches the appropriate motor terminals. That means when you send the signals, the switches work and they control the motor terminals, allowing the current to flow in the desired direction, right? Because the current is a thing that allows the motor to rotate either clockwise or anti-clockwise. Now, this is the automated process. The Arduino can effortlessly manage the motor's behavior, providing efficient control and enabling a wide range of applications in robotics, automation, and other fields requiring precise motor control. Now, you see how much HBridge is important. And moving on to this. Now, zooming in a little bit. The circuit you see on the right with the blue motor is our HBridge circuit. Now you see I have attached these switches and a voltage source, right? Now, on the left side, what you see is an Arduino. Look, we're not that much efficient in Arduino coding or anything like that, but in our CEA complex engineering activity, we're given the task to use Arduino and to make our HBridge circuit automated. Now, what's happening here? On the left, you see some pins. On the left, you see 3 LEDs which are connected to the resistors and which are connected to the pins. These pins are being automated with the Arduino. So the thing is, the circuit that our respected sir gave us, he asked us to remove that circuit and copy to clipboard that our circuit and paste it in here. Now, when we paste it here, this circuit is now automated. It is connected with Arduino. Now, whenever we change the pins, for example, enable or disable pin, our motor will rotate clockwise or anti-clockwise depending on our switch enabling or disabling, right? So, see, when the switch is enabled, the 3 LEDs are working on the left. Now, remember, the 3 LEDs are working, right? When the upper switch is enabled. Now, moving on to the second diagram. You see, when one switch is closed, you see that only one LED is working, making the motor to rotate anti-clockwise, you know. The motor was rotating in a clockwise direction. Now here the motor is rotating in anti-clockwise direction. Now why are we doing this? The purpose of the purpose of connecting Arduino with this motor, this H-bridge circuit, is that, look, you never know how many circuits you are going to make. 1,000, 100, million, you never know. So you're not going to test every circuit manually. It's going to take years. So the most efficient way is to code Arduino, connect Arduino with the H-bridge, and you can make the circuit run for months. It could run for several months. So making the circuit, calculating the efficiency of a circuit, that is it worth it to introduce this circuit to the market or not? So Arduino makes it very helpful to reduce the human work and the circuit becomes much automated. This is how Arduino works. I hope, respected sir, you have understand what I'm saying. Now moving on. This is now. Before moving on, I just want to tell you this is the same circuit that I mentioned earlier, and on the left, the Arduino 308 is being used. The code was provided by a respected teacher who gave us, and we connected the Arduino with our circuit, which made it work. Moving on to experimental calculation now. Experimental calculations are very important. For example, if you are given a circuit to design, you will design the circuit, you will know the components, but you won't understand, you won't get to know that what values should be used. For example, taking the example of a resistor. How do you know that what value of resistors to use? Now this can be done by experimental calculation, by calculating, by writing the data you have and calculating the required results. For example, in our case, we want to calculate the value of resistor. So what we need is IB. Now, what is IB? IB is IC over beta. IB means the current of base equal to the current of collector divided by the beta. Now, given that the maximum motor current IC is 2 ampere, which is the requirement of our project, given that the maximum motor current is 2 ampere, you need to determine the beta value of NPN transistor. Now we have to determine the beta value of NPN transistor. Look for the data sheet of the transistor and find the beta value. The data sheet is very important. Now once you have the beta value, you can calculate the base current. For example, when you have beta, when you have the beta value, you can calculate the base current. You have IC, you have beta, you can calculate IB. Now to calculate the resistor value, you use 1 Ohm's law. Now RB equal to VCC minus VBE divided by IB. This is the formula that can be used to calculate the resistor's value. RB means resistors of the base. Now where VCC is the supply voltage that is being supplied, a DC voltage, so VB is the base emitter voltage of the transistor, which is 0.7. Now moving on to the components, by using all these formulas, you can easily calculate the resistor's value or whatever you need in your circuit, and specifically sticking to the H-bridge circuit. Now moving on to the components explanation. Now as I said earlier, we will be discussing each and every component. Now first of all, the components used in H-bridge circuits include optocouplers, resistors, transistors, diodes, switches, and the motor, which makes the circuit to work efficient. First of all, we will be discussing optocouplers. Now, optocouplers provide electrical isolation between the low voltage control circuit and the high voltage power circuit, protecting the control circuit from voltage spikes. Now, what do you understand? Let me explain it. Optocouplers is an electrical device, an electronic device that is used to prevent high voltage spikes. For example, if voltage source is being used and you have to provide the circuit with 12 volts voltage, right? And accidentally you provided 25 voltage source or more than that. Now what will optocoupler do? Optocoupler will prevent the circuit from damaging, and it will reduce the voltage spikes, right? Depending on the circuit need, it would prevent the circuit from damaging or breakdown, right? And it will prevent the low voltage peaks, it will prevent the high voltage peaks, which will destroy the circuit and separate the low and high voltage peaks, sending forward what the circuit needs to work. Now, second thing, resistors. Resistors are used to limit current and provide appropriate biasing for the transistors and optocouplers. Now, resistors are used to limit current. We all know that V equal to IR. V by I equal to R. R is directly proportional to voltage and inversely proportional to resistors. Greater the value of resistors, lower the value of current will be. Right? Now, moving on to the third part, transistors. Transistors act as switches to control the flow of current through motor. Okay? Diodes. Diodes are used as flyback or freewheeling diodes to protect the transistors from voltage spikes. Now, what is diode doing on a case? Diode is used as a flyby. What does flyby mean? Which means that its responsibility is to protect the transistors from voltage spikes. Now, if a transistor can't hold much voltage, or if it's designed for a specific voltage, it is the duty of a flyby diode to prevent the BJT or the transistor from damaging. Now, the last thing is switches. Switches control the direction of motor rotation. It controls how rotation is going to work. For example, when you turn on one switch, the motor is going to rotate for example, clockwise direction. If the other switch is now the one switch is turned off and the other is turned on, it is going to move in anti-clockwise direction. We will see how does it work. Now, moving on to further description of these devices, bipolar junction transistor BJTs. Now, the NPN transistor in OR circuits are used as switches to control the flow of current. Bipolar junction transistors are used to control the flow of current through the motor. Now, this makes our circuit very efficient, that BJTs are controlling the flow of current. When probably biased and driven, they allow control to flow in one direction or the other, enabling the motor to rotate in both clockwise and counterclockwise direction. Remember, not only the switches are being used to control the flow of current. Here, BJTs, transistors, are also helpful or being used in controlling the direction of motor. Right. Now, what is optical isolation? Sorry about that. Yeah. Optical isolation. Optocouplers or optical isolators are devices that electrically isolate two parts of a circuit while allowing information to pass between them using light. Now I will be showing you the optical isolation, right? In the end, how does PC817 that we use an optocoupler, how does it work? Now for now, understanding how does an optocoupler work? So what happened is that it electrically isolates the two parts. Like there is a gap in the component, right? It gets current, takes input as a current, and then send light to the front part of a circuit, that is an LDR that receives light, right? So it electrically isolates the two parts of the circuit while allowing information to pass between them using light. Now, the component has two parts between in which these are electrically isolated. The one part sends information to the other part using light. They provide electrical isolation. Now, this is called electrical isolation. So, what's happening between the low voltage control circuit and the high voltage power circuit? Like when high voltage enters, it is a high voltage circuit, and when it throws light to the other part and it moves on, it is a low voltage controls power circuit. Now, as we discussed earlier, that the optocoupler helps to protect the controlled circuit from potential voltage spikes getting damaged or noise generated by the power circuit. Now, if we dive deep into the general overview of the main components of an optocoupler. Now, what does optocoupler have? It It has an LED, a photodetector. Now LED is a light emitting diode that emits light or that sends signals that emits light basically. The optocoupler input side typically contains an LED. When a forward voltage is applied across the LED, it emits light. The LED is usually driven by a current limiting resistor to ensure the LED operates within the specified current range. Now what is happening here? It says that a resistor is being used with the LED to prevent it from damaging. So making it to work in a limited current range. The second thing is photodetector. Now what does a photodetector do? The output side of the optocoupler contains a photodetector. Input side had an LED. The output side has a photodetector. The output side of the optocoupler contains a photodetector that detects the light emitted by the LED. So when the LED sends signals, it has a photodetector that detects the light that is being emitted by the LED. It receives the signals from LED. The detector can be either a phototransistor or a photoresistor, depending on the specific optocoupler model. Now, what is a phototransistor? This type of optocoupler uses a phototransistor as a photodetector. The phototransistor is being used as a photodetector, nothing difficult. When light falls on the base region of the phototransistor, it triggers a current flow. So whenever the signal falls on the base region of the transistor, the current begins to flow between the collector and the emitter. The magnitude of the current is proportional to the intensity of the incident light. Now, it says that more the incident light is, the more the current flows. The second part is photoresistor. It is also known as a light dependent resistor or LDR. In some optocouplers, a photoresistor is used as a photodetector. Now similarly, a phototransistor was used as a photodetector. Here, a photoresistor is used as a photodetector. A photoresistor's resistance changes with varying high light levels. For example, when the light is dim, resistance can be low or high depending on the condition. If the light level is high, resistance can be high or low, vice versa. When light falls on the photoresistor, its resistance decreases, allowing the current to flow. So when light falls on the resistor, its resistance will decrease, the current will flow. Now the relation between resistance and the current is inverse. So to use an optocoupler, an input signal is applied to the LED side of the device. In conclusion, to make an optocoupler work, the input signal is applied to the LED side of the device, causing the LED to emit light. Now, this emitted light is detected by the photodetector, which generates a corresponding electrical signal. Now, light emits signal, it goes to the photodetector, which makes an electrical signal. This allows the transfer of information and control signal from one circuit to another while providing electrical isolation, because you see, signals are being sent or received. There is no connection between them, protecting sensitive components of circuits from voltage differences, noise, or potential hazard. This is the description of optocoupler. I hope you understand it. Coming to flyback diode. The flyback diode, also known as freewheeling diode, is connected in parallel with the motor. Now it is very important to connect them parallel with the motor. Now its purpose is to provide a path for the current to flow when the transistor switches off and the motor's magnetic field collapses. Now what is happening here? It says that when the purpose is to provide a path for the current to flow, that flyback diode provides a path for the current to flow. When the resistor switches off, when the resistor switches off, when the resistor becomes off, the motor's magnetic field collapses, because when the switch is off, the magnetic field collapses. Now this protects the transistor from voltage spikes that can occur due to the motor's inductive behavior. Now when the magnetic field collapses, it can result in a voltage spikes. The flyback diodes protect the transistors from damaging from the motor's inductive behavior. As discussed earlier about the resistors. Now, the 330 ohm resistors are most likely used to limit the current flowing into the base of each transistor in the current. Now, the 330 ohm resistors are being attached to the base of the transistor, which is used to limit the current flowing to the base. The 1K resistors might be used as a pull up or pull down transistor for the switches. Now, these resistors are attached with the switches, which help as a pull up and pull down, matching for the optocouplers. The silicon diodes. As seen earlier, we used 4 silicon diodes that are most likely used as freewheeling diodes across each transistor to protect against the reverse voltage spikes. Now, in our circuit, reverse voltage spikes is very important to understand. The 4 silicon diodes are used as a freewheeling diode to protect against reverse voltage spikes that occur during the switching process. Now, also switches are being used, which are mentioned earlier, which are used to control the flow of current, flow the direction of motor. By appropriately closing or opening the switches, you can control the flow of current through the motor and change its rotational direction. Now we are going to understand the working principle of H-bridge. Now, understanding the working principle of H-bridge. The H-bridge circuits operates based on the principle of switching the transistors to control the direction of current flow through the motor. By appropriately switching the transistors, the current can flow in either direction through the motor, resulting in forward or reverse rotation, clockwise or anti-clockwise rotation. When one pair of transistors is switched on while the other pair is off, the current flows in one direction and the motor rotates in one direction. By reversing the switching pattern, the current direction is reversed, making the motor rotate in the opposite direction. Now, what this paragraph is saying, what it is saying is that H-bridge operates on the principle of switching. Now, switching of the transistor is being used to control the direction of current flow through the motor. The transistors are used to control the flow of current that will pass through the motor. Now, by making the appropriate steps for switching, the current can flow either in one direction into the motor or the other direction of the motor, making the motor to rotate in forward or reverse direction. Now, what it's saying is that when one pair of transistor is switched on, when we make a transistor switch on one pair, because we saw that we had 2 resistors on the left side and 2 resistors on the right side that are connected to each other. Now, when one pair of transistors is switched on while the other pair is off, the current flows in one direction. It's common sense that if there are 4 resistors, 2 are turned off, 1 are on, it means that it is going to rotate in one direction. When the other is off, the other is on, other 2 are on, and the other 2 is off, it's going to rotate in the other direction. Similarly, by reversing the switching pattern, the current direction is reversed and the motor rotates in opposite direction. Now, discussing the applications, because H-bridge is very important in industry and it has several vast applications. Now, H-bridge circuits have various applications in real world scenarios. They are commonly used in robotics to control the movement of robotic arms, wheels, and joints. H-bridges are also utilized in the automation system for precise control of motors, in conveyor belts, elevators, and industrial machinery. In the automotive industry, H-bridges are used in electric vehicles for motor control. They are also employed in household appliances such as washing machines, fans, and electric ovens for controlling the motor speed and direction. Now, this paragraph is discussing about the applications of H-bridge, how H-bridge is being used by the real world, by industry. In this paragraph, the writer says that H-bridge has very vast applications. For example, being used in robotics arm, wheels, and joints, and in automation industry, elevators, industrial machine. Like wherever motors are used, an H-bridge can be used, and if rotation of motor is required in clockwise or anti-clockwise direction, an H-bridge can be used. This is how much important the circuitry or the application of H-bridge is, right? Now, moving on to the conclusion. Now, In conclusion, the H-bridge circuit is an essential component in motor control applications as we discussed earlier. It allows for a precise control over the direction of motor rotation, enabling a wide range of industrial and domestic applications. Through the design and implementations of the H-bridge circuit using BJTs, we have successfully demonstrated the ability to control the motor's direction and achieve the objectives of the project. The project highlights the importance of H-bridge circuits in motor control system. Now, what does it say? It says that H-bridge circuit was very important. It helped us to understand the application of H-bridge in motor control system. Now, not only BJTs can be used, MOSFET, JFETs can be used to make an H-bridge depending on our need and our conditions. Now, it allows the precise control over the direction of motor rotation that we discussed earlier. It is a very capable device of making the motor rotate in any direction you want, and it has very high demand in the industry. Now, the last part is the future enhancement. How can we enhance the H-bridge? There are several potential improvements and modifications that can be made to enhance the performance, efficiency, and functionality of the circuit. Some future enhancement may include incorporative motor speed control using pulse width modulation (PWM), implementing protection mechanisms such as overcurrent and overtemperature protection, integrating feedback sensors for the precise positioning, and exploring alternative transistors technologies such as MOSFET for improved efficiency. These enhancements can further enhance the versatility and reliability of the H-bridge circuits in motor control applications. It says that you can add many things, like for example, for the temperature control, you can add integrating feedback sensors to control the temperature you can use in device, and BJTs can be replaced by MOSFETs. So these enhancements can make H-bridge a complete good circuit, rather than a simple H-bridge that we have made in our semester project. And we hope that we will work on it further and make it a good circuit by experimenting, by doing by using different technologies. We can make a good H-bridge circuit. Now, moving on to the video presentation. This is our lab in A block. We are working here on our PCB design. You can see for T blocks, resistors, LM, PC187. Now we are here doing soldering of our circuit. You can see the names Zohaib and Armahan and Ans. Soldering is being done. This is our final result. Now here we using DC supply, and we didn't have a good fan, or a fan. We used you can say something hard that tells whether the motor is rotating or not. So when we connect the battery here, you see the rotation here, anti-clockwise, clockwise and anti-clockwise rotation, you will see, and the motor is rotating in clockwise direction, you see that. Now the motor is rotating in clockwise direction. Now here you see when it is connected, it rotates in the anti-clockwise direction, right? And here it will rotate in the clockwise direction. See, it rotates in the clockwise direction. This is our circuit that we were implementing in our lab. You can see the configuration easily, and the link of this video is going to be attached in the comment part. This is the soldering that we did. This is the final result.